Hello guys, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, I am going to start a new chapter in the Elevate batch, that is complex numbers. In these complex numbers, I will be going to discuss each and every concept from basic to advanced. Complex number, this is a big chapter, so that it requires so much amount of time. That is the reason I have discussed after quadratic equations and matrices and determinants. So this complex numbers is a very important chapter. From these complex numbers, you can expect plus 8 marks in JEE Mains 2024. So it has a two questions weightage in the JEE Mains paper. So I will discuss each and every concept from basic to advanced. You have to listen carefully and watch till the end, so that the main concepts will not be missed, because in complex number, the last concepts, which are De Morgan's and the complex numbers properties, argument, conjugate and modulus, these are very important properties, so you cannot miss them. So watch till the end. And also, if anyone didn't subscribe to this channel, subscribe to this channel and watch till the end, so that you can get a maximum benefit. And also I will be going to discuss some important PYQs in this complex numbers, and I will be discussing at the last or in the middle, wherever possible I will discuss there. So watch till the end. First of all, you have to understand what is meant by complex numbers. What is meant by complex number, and why complex numbers we are using? Why? What are complex numbers? In order to understand what are complex numbers, you have to understand first real numbers. And in order to understand real numbers, you have to understand rational, irrational, integer, whole numbers and natural numbers. These all things you have to understand. These real numbers, rational, irrational, integers, whole and natural numbers, these numbers are called the number systems. But first of all, the first number system is natural numbers. After that, whole numbers came into existence. After that, integers came into existence. After that, rational and irrational, and next real numbers and complex numbers now. But why there is a need of whole numbers after natural numbers, and why there are integers after whole numbers? Because these number systems are failed in some aspects. Suppose if we see the natural numbers, in natural numbers there is no zero is not there, but in whole numbers zero is there. But in whole numbers, negative numbers are not there, but in integers the negative numbers are there. Like that, if we see in every system, in some aspects it is failing. The natural number set starts from 1 2 3 up to infinity, but in whole numbers it is starting from 0. So the problem of 0 is solved by whole numbers, but it is not there in natural numbers. So like this, everything is failed at some instant. That is the rational, irrational and real numbers also failed. The main important thing is why real numbers have failed. Because real numbers have failed, and the scientists, the mathematicians have doubt in one equation. The main important equation is x square plus 1 is equal to 0. This equation leads to complex numbers. Why this equation has this much importance? Because in order to understand this equation, we have to first understand what is this equation. That is x square minus 1 is equal to 0. This is a quadratic equation. We already know in quadratic equation, the degree is 2 and it has 2 roots. So what are the 2 roots here? That is x square equal to 1 and x equal to plus or minus 1. So x equal to plus or minus 1 are the 2 roots, and if I back substitute x equal to plus or minus 1, I will get 0 equal to 0, which is a valid expression in mathematics. But what is the case of x square plus 1 equal to 0? In x square plus 1 equal to 0, if I am going to solve, I will get x square equal to minus 1 and x equal to plus or minus under root of minus 1. But in mathematics, under root of negative number is invalid. It is not valid, because under root of negative will lead to unusual behavior. So we are not going to accept the under root of negative. So because of this, we already know this x square plus 1 is a quadratic equation. The quadratic equation will have definitely 2 roots. So in order to satisfy the 2 roots condition, the mathematicians have assumed this entire thing, that is root of minus 1, as a single term which is said to be I, and I is called iota. If I is the value of root of minus 1, the problem is solved. That is x equal to plus or minus iota. And if I back substitute x equal to plus or minus iota in the given equation, what I will get? I will get plus or minus iota whole square plus 1 equal to 0. Plus or minus 1 whole square is plus 1 only. So I square plus 1 equal to 0. What is I square? What is I? I is root of minus 1. Root of minus 1 whole square plus 1 equal to 0. And root of minus 1 whole square is minus 1 plus 1 equal to 0. So 0 equal to 0, which is valid. So the assumption, that is iota term as root minus 1, has solved the back, that is the back option, that is real numbers. That is the where real numbers is failing, the real numbers is failing under root of minus 1 terms, and this condition is solved by using the iota term, which is root of minus 1 iota, and this leads to the new system, that is a complex number system. Complex number system. It is very important to understand. The complex number system came after real number system. So the real number system has failed in some aspect. The complex number system has solved that problem and came into existence. But the complex number system also failed at some instant. This is not the time to discuss that one, because you are going to learn how complex number has failed in the BTech. So you have to wait up to there. But it has failed in some instance. So the new number systems is scientist is trying to find. Up to now, the complex number system, you have to understand. The complex number system is simply what is the problem the real numbers is facing. The complex numbers has solved that problem by assuming root of minus 1 has iota. And now here comes the starting thing, that is, I said I equal to root minus 1. Now I will find the powers of iota. Powers of iota. What I will get? I equal to root minus 1. Okay. What is I square? I square equal to root minus 1 whole square. That equal to minus 1. What is I cube? I cube equal to I into I square. So what it will become? I into what is I square? It is minus 1. So it will be minus I. And what is I power 4? I power 4 is I square into I square. I square is minus 1. Minus 1 into minus 1 equal to 1. And next thing is I power 5. I power 5 is I power 4 into I. What is I power 4? I power 4 is 1. 1 into I is I. Like this you can solve. Now here comes the important observation. If I see here, that is 2, 3, 4, 5. These are the consecutive powers of iota. The consecutive powers of iota. And what if I do the consecutive powers addition? That is I square plus I cube plus I power 4 plus I power 5. If I do addition of these values, what are these values? These values are minus 1, minus I, plus 1 and plus I. And what is the summation value? The summation value is 0. So here comes an important observation, that the consecutive powers of iota, the 4 consecutive powers of iota, these are 4 consecutive. These are 4 consecutive powers of iota. So the summation of these 4 consecutive powers of iota gives the values 0 as answer. This is the thing you have to remember. And next comes the important, that is a representation. The representation of, what is the representation? Representation of complex number. How complex number is represented? We already know how real number is represented. Now comes the complex number representation. The complex number is denoted by the letter Z. Z is equal to A plus I into B. This is a representation for a complex number. If you see the video thumbnail, I mentioned here Z equal to A plus IB. And if you see there, I mentioned A and B as real. But iota into B mentioned as imaginary. I have written like this in the thumbnail. So you have to understand what is this thing. That is Z equal to A plus IB is a representation. You already know. Suppose if I deal Cartesian system. In the Cartesian system, what are the values present? X comma Y are present. Suppose 2 comma 3. If I see the point 2 comma 3, 2 comma 3 is a point here. 2 comma 3. So 2 comma 3 is represented by X axis and Y axis. So these two axes are real. These two axes are real axis. But in the complex number, as it is complex with the iota which is imaginary, this entire iota into b is now becomes a new value, that is new value which is imaginary. So in order to represent this iota b, basically this z is a comma iota b. Basically this is a representation of z, a comma iota b. But z equal to a comma z equal to a comma iota b. It is very important to understand that is what is Cartesian. The Cartesian is a representation of values, that is 2 comma 3, it is represented here. But the most important thing you have to understand, that is in the complex representation these two are not same. Here a is real and b is real, but the combination is complex. So in order to represent this complex, you have to use one axis, that is imaginary axis. So in representation of complex number, we are going to use another plane. Here we are using the Cartesian plane, but here we have to use the argand plane. This complex number representation plane is called argand plane, and a comma ib are represented here. Suppose a comma ib point is here. This is a complex number, but the axis which is a representing is real axis. But here the ib which is representing, it is called imaginary axis. This is the main difference between the Cartesian system and the argand system. In the Cartesian system, both axes are real axis. But in the representation of complex number, in order to represent a complex number, it is very important that this complex number a is represented on real axis, but ib is represented as imaginary axis. So if I take an example of a complex number z equal to 2 plus 3 iota, z equal to 2 plus 3 iota, what I will get? I will get 2 values I have to move here, so I will get here, and 3 values I have to move, because 1, 2, 3, these are the values, but here iota, 2 iota, 3 iota are the values. So 2 comma 3 iota, 2 will be here, but here 3 iota I have to move here, because this is the real imaginary axis, iota, 2 iota, 3 iota. But in real system, the y-axis will be 1, 2, 3, but here iota, 2 iota, 3 iota, because this is the imaginary axis. So in order to represent a complex number in the argand plane, we are using the real axis and imaginary axis. But in the Cartesian system, in order to represent the point, we are using the real axis, both real axis, x-axis and y-axis. This is the important point you have to understand. And next, now I already said the main representation of complex number is z equal to a plus ib. Now we are going to deal with first property, that is equality property. Equality property. What is equality property? Now we are going to understand the operations on complex numbers. Operations on complex numbers. So we are going to understand what are the operations we can perform on complex numbers. Basically, in any system, we can add two numbers, we can subtract two numbers, we can multiply two numbers, we can divide two numbers. Like that only, there are so many operations which are going to perform in complex numbers. So in order to perform operations on complex numbers, it is very important, we require two complex numbers. So I am going to define two complex numbers as z1 equal to a1 plus iota b1 and z2 equal to a2 plus iota b2. So these z1 and z2 are the two complex numbers. And now the first property I am going to discuss is equality property. Basically, equality property says that the z1 complex number, when z1 complex number will be equal to z2 complex number, this is a observation. How we can say two complex numbers are equal? These two complex numbers are equal if and if only the real, here a1 is called real, this is called imaginary. So the real is equal to real. If real is equal to real, then it is equal, and imaginary should be equal to imaginary. Imaginary should be equal to imaginary. Imaginary should be equal to imaginary. What does it mean? The real is equal to real. What does it mean? That is a1 should be equal to a2 And what is imaginary equal to imaginary? That is b1 is equal to b2. If these two are equal, we can say z1 is equal to z2. So this is the equality operation. Now comes the second one, that is addition. Now what is addition? That is, we have to add two complex numbers. How we can add two complex numbers? Similar. That is, like attracts like. That is, z1, in the z1, what is the real part is present, it will attract the real part of second complex number. That is, in the z1, what is the real? That is a1 plus iota b1. This is a complex number, z1. And z2 is a2 plus iota b2. So the real attracts real. So a1 will attract a2. So we can add these two directly, a1 plus a2 plus iota into, again we have to add imaginary to imaginary, that is b1 plus b2. So like this the addition will be performed. The real cannot be added to imaginary, the imaginary cannot be added to real. Only real should be added to real and imaginary should be added to imaginary. If you observe carefully, a1 plus a2 is another real part, that is I can mention as a3 suppose, plus iota into b1 plus b2 is another imaginary, that is b3. So if you observe carefully, a1 plus iota b3, it is also a complex number. It is also a complex number. What does what infer you can take from this? Because this the main important observation here is, any operation performed on complex number does not change its nature. That is, I performed addition, I performed multiplication, I performed division, anything you can do, but the result is again a complex number. The nature of the complex number does not change. Next, the third operation is subtraction. How subtraction is performed? Subtraction is simply the subtraction of two complex numbers, that is z1 minus z2, that is a1 plus iota into b1 minus a2 plus iota into b2. Yes, a1 plus iota b1 minus a2 minus iota b2. Simply subtract the real, that is a1 minus a2. Simply subtract the imaginary to imaginary, that is b1 minus b2. So again this is a complex number. So like this the operation is performed. Now the fourth operation, that is multiplication. The fourth option, multiplication, that is z1 we have to multiply with z2. So it will be represented as z1 z2. How the multiplication is performed? That is a1 plus iota b1, it should be multiplied with a2 plus iota b2. a2 plus iota b2. This is same as a plus b whole square, that is a plus b into a plus b. How this multiplication is performed? First element should be multiplied with two elements, that is a into a, it is a square, and a into b, it is ab. And second element is performed again multiplication, that is ab plus b square. Like this only we have to do multiplication with every element. That is a1 is multiplied with a2, that is a1 a2 plus iota a1 b2. Again this element should be multiplied with this one and this one. So iota a2 b1 plus iota square b1 b2. Yes. Now a1 a2 is real, and if you observe carefully here, iota square is came. What is iota square value? Iota square is minus 1. So minus 1 into b1 b2 is minus b1 b2. Yes. Plus if I take common iota here, I will get a1 b2 plus a2 b1. So again if you observe, this is again a complex number. And next, division. In division we have to understand one thing, that is rationalization, because z1 when we divide with z2, that is a1 plus iota b1 divided by a2 plus iota b2. After performing the thing, we have to separate real and imaginary, but without doing any operation we cannot perform, that is we cannot perform division. So what we have to do? We have to introduce one concept, that is rationalization. What is rationalization? The rationalization concept says that we have to multiply the opposite sign of any of the numerator and denominator as two times, that is numerator we have to multiply and denominator we have to multiply, that is a1 plus iota b1 divided by a2 plus iota b2. This thing you have to multiply, that is I can take denominator as a reference. So if I take denominator as a reference, I can take a2, here plus it is, so I have to take minus, divided by, again I have to divide with same. So doing this is called rationalization. So when I do this thing, I have to multiply. So multiplication I already said, that is a1 plus iota b1 multiplication of a2 minus iota b2 divided by a2 plus iota b2 into a2 minus iota b2. Yes. So in the numerators I can multiply, that is a1 is multiplied with a1 a2, that is a1 a2 minus iota a1 b2 plus iota a2 b1 minus iota square b1 b2. Yes, entire thing is divided, and this is a plus b into a minus b, that is a2 square minus iota square b2 square. Yes, so if you observe carefully, this is a1 a2 minus iota a1 b2 plus iota a2 b1, and here I square is minus 1 into minus, it is plus b1 b2 divided by, it is a2 square, okay, but here it is minus I square is plus 1, so plus b1 b2 square. And if I write neatly here, that is a1 a2 plus b1 b2, if I take count iota, that is a1 b2 minus a2 b1, this entire thing is divided by a2 square plus b2 square. This is a generalization, that is the thing, it is taking this much space, that is z1 and z2. So this is the answer. Like this you have to solve. But there is no need to remember this entire thing. Suppose if I give 2 plus iota divided by 5 plus 3 iota, you have to divide this. Simply you have to multiply with 5 minus 3 iota divided by 5 minus 3 iota. And you have to perform normal computation. And after computation, you will simply get another complex number. Here. This thing you have to find. But there is no need to by heart this formula. And two important relations you have to remember, that is 1 plus iota whole square is equal to 2 iota, 1 minus iota whole square is equal to minus 2 iota. Direct in any equation, if I give this 2, you have to directly write 2 iota minus 2 iota, because if I open this, I will get 1 plus I square plus 2 iota, and I square is minus 1, it will cancel, and here also same thing, 1 plus iota square minus 2 iota, this thing or cancel, so I will get 2 iota minus 2 iota here. Now the important concept is square root. Square root of a complex number. I already said any operation performed to square complex number does not change its nature. So what is the square root of a plus iota into b? It is also another complex number, that is x plus iy. X plus iy is another complex number, and if I do the square root of a plus ib, I have to get x plus iy. So what is the relation here? I have to simply square on both sides. I will get x plus iy whole square. If I do square, the root will be cancelled. Yes. So if I open a plus iota b is open, and x square plus iota square y square plus 2ixy. Yes. So a plus ib is equal to x square. I square is minus, so minus y square plus 2xyi. Yes. Now what we have to do? We have to compare. I already said this is a complex number and this is also another complex number. So the complex number, when two complex numbers are equal, when real is equal to real and imaginary equal to imaginary. So this is real. So there is real is equal to real, that is x square minus y square equal to a, and the imaginary should be equal to imaginary, that is 2xy is equal to b. So now we have to solve these two, and we have to find the relation, that is what is the value of x and what is the value of y. The answers I will write here, because it is there is a time constraint, we have to do fast, that is we have to complete the entire concept. So that is the reason I am keeping here only, that is x square minus y square equal to a and 2xy equal to b. Just we have to simply substitute y equal to b by 2x in this equation and solve the value of x. That's it, you will get answer. So I am going to write this answer, that is x square is equal to root of a square plus b square plus a by 2, and y square is equal to root of a square plus b square minus a by 2. This x square y square will get two answers. So that is the reason after computation x plus iy is not the answer. What is the actual answer? Plus or minus, because two values you will get, plus or minus here the x value plus iota y value. This is the answer. Here x and y are without sign. Suppose if I take an example, find the square root of 3 plus 4 iota. What I have to do? I have to find x square. X square equal to, what is the formula? Root of 3 square plus 4 square plus 3 divided by 2. And what is y square? Y square is root of 3 square plus 4 square minus 3 by 2. Find these values. This is 5 plus 3 by 2. 5 plus 3 by 2, it is 8 by 2, that is 4, and it is 5 minus 3 by 2, it is 2. Hello, am I audible, guys? Hello, hello. Yes, it is audible. So I got x square is equal to 4 and y square equal to 1. So x equal to plus or minus 2 and y equal to plus or minus 1. So these values you have to write now. That is plus or minus of 2 plus iota. That's it. This is the answer. Hello, hello. Now if you observe, the next concept is I will discuss the three main concepts. That is, the first concept is modulus, and second concept is conjugate, and the third concept is argument. These three are the important concepts. That is argument. Now you have to understand what is modulus, what is conjugate, and what is argument. What is modulus? Modulus of a complex number. Modulus of a complex number you have to find. What is a modulus? Modulus definition, simply you have to understand the definition. Modulus is nothing but distance from origin. Distance from origin. Suppose z is a complex number. Suppose I am representing z here. The distance, this distance is said to be modulus. That is, the distance of a complex number from origin is defined by modulus, that is the modulus of z, and this answer is root of a square plus b square. Simply, what is a square? A value and b value, that is a plus iota b is a complex number. You have to find the distance from the origin. What we have to do? We have to simply square the real part and imaginary part, that is a square plus b square. If you do the square, what is the result you will get? That is the distance from origin. Suppose 3 plus 4 iota is a complex number. You have to find what is the modulus of this complex number. That is z is equal to this complex number. So what is the modulus of this complex number? It is a square root of 3 square plus 4 square. Yes. What is the under root of 3 square plus 4 square? It is 25. It will be 5. So the modulus is equal to 5. So the modulus value is actually a constant which is equal to 5. So this is the modulus. But the modulus, for modulus there are some properties. That properties you have to understand. What is modulus? The modulus, if I do, this modulus is equal to this modulus is equal to this modulus, and this modulus is equal to this modulus. That is, any operation, the negative of complex number, this is conjugate, I will explain. This is the negative of conjugate. This entire thing is equal. That is, the modulus does not change by performing any operation on a complex number. It is very important. And next thing, that is, the modulus can be splitted. That is, z1 into z2 is another complex number. That modulus is the same as modulus of z1 into modulus of z2. This is the determinant property, you can say. And the division also, that is z1 divided by z2, you can divide, that is modulus of z1 divided by modulus of z2. Like this you can do. Another thing, that is the modulus of z power m is same as, you can write z into z like this up to m times. So it will be modulus of z into modulus of z into modulus of z into modulus of z, like that. It will be modulus of z whole power m. So this can be interchanged. So these are the properties. And now I will discuss argument. What is argument? Argument is the angle made by the complex number with the positive x-axis. What is the angle made by the complex number with the positive x-axis is said to be argument, and it is defined as ARG of z. ARG is nothing but argument of z, and argument of z will depends on the quadrants. It is very important. That is, it is an angle. So suppose if I take the first quadrant case, first quadrant if I take, this is a complex number. Suppose it is a comma b point. So this is this value is a and this value is b. Suppose if I take theta here, what is tan theta? Tan theta equal to b by a. What is theta? Theta equal to tan inverse b by a. So in the first quadrant, theta equal to tan inverse b by a is an angle made with the positive x-axis. So this is said to be argument. That is argument of z is equal to theta here. What is theta? Theta equal to tan inverse b by a. So this is the answer for the first quadrant. What if the argument is present in second quadrant? That is, if it is second quadrant, the argument is now this one. That is theta this one. But the entire angle is pi. This entire angle. So if I subtract alpha angle, that is pi minus alpha, this thing will be equal to theta. So pi minus alpha will be equal to theta. What is theta? Tan inverse b by a. So we have to subtract this thing. That is pi minus alpha. This alpha can be calculated. This alpha can be calculated again. That is this alpha is same as this only. But the main important thing is theta we have to remember. Basically, not this is a relation. 1 second, I will erase this relation because it is not the correct. The main relation is, if you observe carefully, this theta plus alpha will give pi. Yes. So in order to find theta, what I have to do? I have to do pi minus alpha. Pi minus what is alpha? Alpha is a calculation of same theta. That is tan inverse b by a, because this is a comma minus a comma b. So this is a value of a, this is a value of b, again alpha, tan inverse b by a. So now theta will become this one. So what is argument in the second quadrant? Argument of z is equal to pi minus tan inverse b by a. And here theta, this can be taken as alpha. Theta is equal to alpha in the first quadrant. In the second quadrant, theta, that is theta equal to pi minus alpha. That is pi minus tan inverse b by a. And now the third quadrant. If this is the third quadrant, this angle is negative, that is minus pi. If I add plus alpha, I will get minus pi plus alpha as an argument. So argument of z is equal to minus pi plus alpha here. So that is minus pi plus tan inverse b by a. I will take one example and discuss. This is the third quadrant case. This is the third quadrant, and this is the second quadrant. This is a third quadrant and this is a fourth quadrant. That is, if this is like this, if this is theta, suppose it is like this, it is theta, and what is this one? It is minus theta. So simply here we said theta equal to alpha, here theta equal to minus alpha. So that is minus tan inverse b by a is the angle here. So here what is argument? Argument of z is equal to minus alpha, that is minus tan inverse b by a. Like this you have to remember. So if I generalize everything, first quadrant, what is first quadrant? That is theta equal to alpha, here theta equal to pi minus alpha, here theta equal to minus pi plus alpha, and here theta equal to minus alpha. And what is alpha here? Alpha equal to tan inverse b by a. Like this you have to remember. Now I will take one example, that is 1 plus root 3 iota, 1 minus root 3 iota, minus 1 minus root 3 iota, minus 1 plus root 3 iota. If I take 4 different complex numbers, this complex is first quadrant, this complex is, that is positive and negative, this is fourth quadrant, this one is third quadrant, because in third quadrant the real and imaginary both are negative, and this is second quadrant. So what is the first quadrant argument? First quadrant argument is what? Simply theta equal to alpha. Fourth quadrant argument is theta equal to minus alpha. Third quadrant argument is theta equal to minus pi plus alpha, and second quadrant argument is pi minus alpha. So what is alpha here? Tan inverse b by a. So tan inverse, what is b? B is this one, root 3. Root 3 divided by what is a? A is 1. So tan inverse root 3. What is tan inverse root 3? Tan inverse root 3 is pi by 3. So alpha equal to pi by 3 here. This is the argument, and this is minus pi by 3, and this is minus pi plus pi by 3, and this is minus pi, and this is minus pi minus pi by 3. That is pi minus pi by 3. So this is argument of z is equal to pi by 3 here, and argument of z is equal to minus pi by 3 here, and here argument of z is equal to minus pi plus pi by 3, that is minus 2 pi by 3. Here the argument of z is 2 pi by 3. So if you observe carefully, the argument is different in different quadrants. So you have to remember these formulas. The first quadrant, second quadrant, third quadrant, fourth quadrant. What are the formulas we have used? That is theta equal to alpha, theta equal to minus alpha, theta equal to minus pi plus alpha, theta equal to pi minus alpha. You have to understand very carefully. This is argument. Now this is the argument, and I have discussed the argument and I have discussed the modulus. Now comes the important, that is conjugate. What is a conjugate? Suppose z is a complex number which is represented here, z. What is a conjugate? Conjugate is represented by z bar. So what is z bar? Z bar is the mirror image of this complex number with the real axis. Real axis. If real axis is a mirror, suppose real axis is a mirror, if the reflection of z with respect to real axis is this one, this is said to be z bar, which is said to be conjugate of z. Conjugate of z. So the distance is not changing, so our modulus is not changed. That is the reason the z and z bar have the same modulus. And the argument also, if you observe, if this is argument theta, this argument is minus theta. So here if it is pi by 3, it is minus pi by 3. So the conjugate you have to understand very carefully. That is argument of z is equal to minus of argument of z bar. You can understand like this. And there are I forgot to remember, that is there are so many properties for argument. That is argument of z1 into z2. It takes the logarithms, that is argument of z1 plus argument of z2. Like this you can represent. And what is argument of z1 by z2? It is simply argument of z1 minus z2. Argument of z2. But one most important thing I have forgotten, that is, if this is a complex number, this is a complex number, and this is a complex number. If you observe carefully, this can be a modulus. This is the argument, this is the argument, and this is the argument, or this is the argument. It is true. But here it can be less than pi, or it can be greater than pi. Which we have to accept? This angle or this angle. Both are the arguments. But in arguments there are two types. That is principal argument, principal, general. What is general argument? General argument is any argument. Any argument. What is principal argument? What is principal argument? The principal argument where theta is lying between minus pi and pi. If this is a range of the theta, it is called as principal argument. If the argument is other than this theta, it is said to be the general argument. Now conjugate. Now conjugate has some properties, that is z1 plus or minus z2. If I take bar, the bar will be splitted, z1 plus or minus z2 bar. But it is not in the case of modulus. In the modulus, only multiplication and division has this property. And one more thing, sometimes I already said what is z equal to a plus ib. If you observe carefully, this a is real and b is real. you have to understand when z is purely, when z is purely, when z is purely real. Sometimes it will be given z equal to a plus ib. So z is purely real. Sometimes they will ask like this in the question. If you observe carefully in the question, sometimes they will give z is purely real. In that case, what we have to do? If z is purely real, no imaginary term should be present. That is, ib should not be present. So b is equal to 0. When b is equal to 0, a is only present. So when a is only present, the complex number is said to be purely real. And when a equal to 0, that is, real part is 0, there is only imaginary part. So in that case, z is said to be purely imaginary. Purely imaginary. Z is said to be purely imaginary. And next, these are the properties of the conjugate, and I already discussed modulus, argument, and the conjugate. Now representation of a complex number. Representation of a complex number. How complex number is represented? I already explained. The complex number is represented by using argand plane. By using the argand plane, we can represent by using the complex number. Hello. By using the argand plane, we can represent any complex number. So by using the complex number, what we can do? We can represent that in the argand plane, and we can perform many operations. So there are so many methods to represent the complex number. The first one is Cartesian system. That is a Cartesian plane. In the Cartesian plane, by using the argand plane, we can represent the complex number. And the second is polar form. I will discuss each form. That is polar form. Another form is trigonometric form. Trigonometric. How the complex number is represented in this? Suppose z is equal to some complex number you can take. That is, z is equal to r into cos theta plus iota sin theta. This is a form of polar as well as trigonometric. That is r into cos theta plus iota sin theta. Suppose if there is a complex number that is 1 plus root 3 iota, I have to represent this as like this. How I can represent? Simply find argument. How you find argument? You have to see the what you have to show about. You have to see the quadrant. This is the first quadrant, and what the first quadrant argument is theta equal to tan inverse b by a. That is tan inverse root 3 by 1. So the theta is equal to the చేద్దాం పైగా అడిసినట్టు ఏం చూస్తా కదా theta equal to pi by 3. So here the argument is theta equal to pi by 3. So the theta I can write directly pi by 3, and I have to find r. What is r? That is modulus of z. So the modulus of z is called the that is modulus of z, that is root of 1 plus root 3 whole square. That is root of 1 plus 3, that is root 4. What is root for it is 2. So the complex number 1 plus root 3i can be represented by the polar form, that is r into cos theta plus iota sin theta. What is r? R is 2. 2 into cos theta, that is cos pi by 3 plus iota sin pi by 3. So this is a representation. Like this you have to write the complex number. The next form is Euler form. Why the need of the Euler form? Because in the simplification, Euler has designed one form, that is a Euler form. In this form, the r into cos theta plus iota sin theta, it is very important, you have to understand, that is r into cos theta plus iota sin theta. This entire cos theta plus iota sin theta, the Euler has represented as e power I theta. So now the Euler form is r into e power I theta. The form has reduced. That is e power I theta. Now e power I theta is equal to cos theta plus iota sin theta. This can be proved, but it is not needed. That is e power I sin theta is equal to cos theta plus I into sin theta. That you can prove by taking the expansion of cos theta and sin theta and e power I theta expansion, and entire thing, if you see, the LHS is equal to RHS. Like this you can see this. Now very important. Now we are discussing with the locus representations. Now we will discuss the locus representation. How with the help of the locus we can see how the complex numbers are doing in the locus. That is, I already said, what is argument of z? That is equal to theta. So this argument of z we can represent as z minus 0, that is theta. So what it implying? That is, it is 0, which is said to be origin. So from origin it is extended, and with origin it is becoming theta. What if it is argument of z minus z1 equal to theta? That is, it is a difference of the angle. That is, z is a one complex number, z1 is another complex number. The angle made between these two, suppose z is this complex number, you can visualize like this. This is z1 and this is z, and z minus z1. This angle is called now this one. So we have to remember, very important. It is very important, guys. This is a thing you have to remember, that is argument of z minus z1 is equal to theta. So if you observe carefully, this is a locus. It is representing as locus. That is, if we see argument of z minus z1, that is equal to theta. I already said. But what if it is less than or equal to 0? That is, it is less than 0. It means it is showing below axis. It is a region it is showing. And what it is greater than or equal to theta, it will be showing above region. So in complex number, there are locus representation quotients. In that quotient, they will be giving us some argument of z minus 3, z minus 5, z minus root 3, like that. So what we have to do? We have to check whether it is showing the region of the line, or it is below the line or above the line. You have to see. Now, if you observe carefully, sometimes it will be giving like this. Modulus of z is equal to r. What is modulus of z? Modulus of z is square root of a square plus b square. It is r. So a square plus b square equal to r square. So what does it imply? It is implying an circle. Yes, this is a circle of how much radius? It is a circle of radius r. Like this only, if I see modulus of z minus z naught is equal to r, here z naught is the center. Z naught is the center and r is the radius. You have to remember this. Z naught is the center and r is the radius. Z naught is the center and r is the radius. And if I open this, I will get same. Suppose center, if it is 0, 0, this thing you will get. But if center is somewhere, that is x comma y, what you will get? You will get x minus x1 whole square plus y minus y1 whole square. Y minus y1 whole square is equal to r square. This thing you have to remember. And next important thing, same here also, that is modulus of z and modulus of z minus z naught. If this is r and this is less than r and this is greater than r, if this is a circle, it is representing a circle, this is a circle, If it is equal to r, it is representing on the circle region. This on the circle region it is representing. But if it is less than r, it is representing inside region. And if it is greater than r, it is representing outside. It is representing outside region. Entire outside region is represented. Now we are going to discuss one important theorem, that is De Morgan theorem. De Morgan's theorem. What De Morgan has given two important theorems. The first theorem is cos theta plus iota sin theta whole power n. This thing can be same as cos n theta plus iota sin n theta. That is, the power is multiplied with the theta. Why it is possible? That is, cos theta plus iota sin theta is e power I theta. E power I theta whole power n is e power I theta whole power n is e power n theta, e power I n theta. So n theta is a new angle now. N theta is a new angle. That is the reason we are representing like this. And the second important statement the De Morgan given is cos theta plus iota sin theta whole power some rational terms, that is p by q. What the term you will get? You will get cos of p theta plus 2k pi by q plus iota sin p theta plus 2k pi by q. Why we can, if we observe carefully, I can directly multiply from the previous one, that is cos p theta by q plus iota sin p theta by q. But here we are adding 2k pi again, because in order to generate the principal argument, we are adding this one. So now this is the entire thing we have to evaluate, 2k pi. So that this is the reason why we are adding cos of p theta plus 2k pi. This is the De Morgan theorem. These two statements are important. Suppose if I given one complex number, that is 1 plus root 3. What I represented here, 2 into cos pi by 3 plus iota sin pi by 3. This thing I have represented. Yes. So 2 into cos pi by 3 plus iota sin pi by 3. What if I multiplied whole power 3? This thing also multiplied with whole power 3. That is 2 cube, it is 8. 8 cos 3 pi by 3 plus iota sin 3 pi by 3. 3 will get cancelled. 8 of cos pi plus iota sin pi. This is the answer. And next important concept is cube roots of unity. What are cube roots of unity? Suppose z is a complex number, z cube is equal to 1. Suppose z cube is equal to 1. What are the values of z? How many values of z can be we got? This is z cube minus 1 equal to 0. Yes. So z cube minus 1 is z cube minus 1 cube. That is a cube minus b cube. That is a minus b. That is z minus 1 into z square minus z plus 1. So z is equal to 1 is one thing, and z is equal to minus 1 plus or minus root 3 iota by 2 is another one. So that is minus 1 plus root 3 iota by 2 and minus 1 minus root 3 iota by 2. So these z equal to 1, z equal to this one, z equal to this one, these three are said to be cube roots of unity. These three are said to be cube roots of unity. These three are said to be cube roots of unity. How we can find the cube roots of unity? By normal process, by using De Morgan. That is z cube equal to 1 the given. Z is equal to 1 power 1 by 3. Yes, it is considered as p by q. So now we have to represent 1. So 1 how we can represent? We can represent at 1 by cos 0 plus iota sin 0 whole power p by q now, that is 1 by 3. So z is equal to cos of p theta, that is 1 into 0, it will be 0. So what we will get? 2k pi by 3 plus iota sin 2k pi by 3. Yes. Now here the what is a k value? K value will go from 0 to q minus 1, that is denominator minus 1, that is 0 up to 3 minus 1, it is 2. So the k values can be 0, 1, 2. Yes. So k is 0. Z is equal to cos 0 plus I sin 0 is one value. Now another value is Z is equal to cos 2 pi by 3 plus iota sin 2 pi by 3. And what is the third value? Third value is cos 4 pi by 3 plus iota sin 4 pi by 3. Yes, these three are the cube roots of unity, and this value is 1, this value is minus 1 plus root 3 iota by 2, and this value is minus 1 minus root 3 iota by 2. And this Z equal to 1 is one value, 1, and this is called as omega, and this is called as omega square. With this, there comes an important properties, that is sum of cube roots. What is the sum of cube roots of unity? That is 1 plus omega square. What is the sum? The sum is 0. And what is the product? Product of cube roots of unity, that equal to 1 into omega square, that is omega cube. Omega cube value is 1. These results you have to remember. Now we have discussed the cube roots of unity. What is the value of nth roots of unity? That is nth root of unity. It is very important. That is, what is the value of nth root of unity? You have to find the answer. That is how we can find the nth roots of unity. Similar thing, that is z power 1 n is equal to 1. Z is equal to 1 power 1 by n. So z is equal to 1 can be represented as cos 0 plus I sin 0. Yes, cos 0 plus I sin 0 whole power 1 by n. So z is equal to this thing similar to cos theta plus I sin theta whole power p by q. For this one, the De Morgan has given one theorem. The second theorem of De Morgan says that p theta plus 2k pi by n plus iota sin 2k pi plus n 2k pi, one second, it is not 2k pi plus p theta by n, that is by q, because here the value is q now. So this is the case. This is the De Morgan, and the value is this one. So similarly I am doing same, that is cos of p theta, that is 1 into 0, it is 0, so 2k pi by denominator n plus iota sin 2k pi by n. And what is the value of k here? K is from 0 to n minus 1. So z is equal to cos 0 plus I sin 0 is one value, and z is equal to cos 2 pi by n plus I sin 2 pi by n is another value, and z is equal to cos z equal to 1 2 now, that is 4 pi by n plus I sin 4 pi by n. Like this, the nth roots will become. So this is 1, this is some value e power I 2 pi by n, and this is e power I 4 pi by n. And one thing I forgot to say, that is the cube roots of unity. If I plot in the region of the graph, what I will get? Suppose this is a plane. If I plot, that is z equal to 1. Z equal to 1 is this one, and this one, these points. That is, this is z equal to 1, and minus 1 by 2 plus root 3 by 2. This value, that is minus here plus here, this value, and here same. And if I join here, this is an equilateral triangle. This is an equilateral triangle with the side root 3. This is the result you have to remember. Same the case with nth roots of unity. If I plot all the roots of nth roots of unity, it will form a circle. It will form a circle, and the points are equidistant. The points are equidistant, very, very important. The points are equidistant here. That is, suppose this is a 1, and next is alpha square, and up to alpha power n minus 1. So the distance between 1 and alpha power n minus 1 and 1 and alpha power n, these two are the distance same. That is, these two are the equidistant, because it is a circle of radius, equal radius now. So these values are equal. And now what are the what are the sum of nth roots? What are the sum of nth roots of unity? It is very important. What is the sum of nth roots of unity? You have to understand. The sum of nth roots of unity can be calculated, that is 1 plus alpha square and so on up to alpha power n minus 1. Suppose it will depend. The summation is always 0, that is sum is equal to 0, because in the cube roots of unity and the fourth roots of unity always the sum is 0. And now the product of roots, the sum is equal to 0 and the product is equal to this entire thing, that is 1 into alpha square up to alpha power n minus 1. So when this multiplication will become alpha power n into n minus 1 by 2. So here it will become two cases. In the cube roots of unity, what is the product? The product is 1. In the fourth roots of unity, the answer is minus 1. So if n is odd, it will be 1, and if n is even, it will be minus 1. So it will depend on the case. Now again another important topic, that is geometry. Geometry of complex numbers. What is the geometry involved in complex numbers? Because the geometry numbers, complex numbers is very important. That is a geometry, how the complex numbers are defined. You already know the z1 is a complex number. Suppose this is a complex number z1. You already know it will makes an angle theta, and z1 can be represented in trigonometric, polar as well as other formats. And this representation will lead to the geometry. That is, this is z1 and suppose there is a z2. The different complex numbers will do different operations. That is, the difference of the angle and some more operations will be performed. That is, z1 is here, and the difference z1 minus z2 will give the distance. What is the actual distance? That is z1 from z1 z2. If I do z1 minus z2, this is the distance between z1 and z2. This is the important thing you have to understand. Suppose this is a z1 and this is a z2. If I do modulus of z1 minus z2, what I am getting? I am getting the distance between the z1 and z2. Suppose like this. This is z and this is z1 and this is z2. What is z minus z1? This is the distance. Z1 minus z2, this is the distance. If I add these two distances, I will get z minus z2 distance. So the z is present at the last. You can see this is the result. And like this also, there are section formula. The complex number part is completed, but now comes the section part, that is section formula. How the section formula is defined? In the section formula, you already know that is two complex numbers are defined, that is z1 and z2. These complex number, two complex numbers are divided in the ratio m is to n. How we can calculate that complex number? A complex number z is dividing two complex numbers z1 and z2 in the ratio m is to n. That complex number is same as mz2 plus nz1 divided by m plus n. If it presents in the middle. Suppose if z1 is here and z2 is here and z is dividing in the external part, that is m is to n ratio. What is the answer now? mz2 plus minus nz1 divided by m minus n. This is the answer if it is dividing externally. And now now comes the midpoint, that is z is equal to z1 plus z2 by 2. You already know when it is a midpoint, m is 1 and n is 1, that is 1:1 ratio, it will divide. And now comes the concept of rotation. That is, suppose this is a complex number. This is a complex number z1 and this is a complex number z2. z1 is making an angle theta and z2 is making an angle alpha. So here if you observe carefully, that is z1 is equal to e power I theta and z2 is equal to e power I alpha. But if I observe carefully, if I take this as theta 1 and this as theta 2, there is no problem. So I can take alpha here, alpha 1, alpha 2. And what we can do, that is the difference. How we can make the difference here? This angle is theta 2 minus theta 1. Theta 2 minus theta 1. So when I divide these two complex numbers, Z1, Z2 divided by Z2, Z1 divided by Z1 by Z2, I will get e power I theta 1 divided by e power I theta 2. So Z1 is equal to Z2 into, that is Z1 I have to multiply, that is e power I into theta 1 minus theta 2. So Z1 is simply Z1 into e power theta 1 minus theta 2. Simply e power I theta 1 minus I theta 2. You have to remember like this. That is, we have to just multiply the angle. That is, if I want to rotate Z1 like this, we have to multiply this angle, that is e power I of theta 1 minus theta 2. If I multiply, I will get the required rotation, that is required complex number. That is, any complex number can be rotated in the organ plane, but the rotation should be, we have to multiply the previous. Suppose 1 plus root 3 here. If I want to rotate by 60 degree, what I have to do? I have to multiply. That is 1 plus root 3 is 2 into e power I pi by 3. That is 1 plus root 3 representation. And I have to rotate into 60 degree. That is, I have to multiply e power I pi by 3 again. What I will get? E power I 2 pi by 3. This is a new value. This is a new value. That is new complex number I will get. That is how much degree I have to multiply. That much e power I have to multiply with the given complex number. This is the thing you have to do. And now comes the important results, that is multiplication. Multiplication by minus 1 I, minus I, omega and minus omega. Suppose if I take z is equal to e power I theta, if I multiply by minus, that is equal to minus z. What does it imply? That is minus 1 into z. And what is minus 1? When the complex number will give minus 1? When it is e power I pi. So into z. And what is the argument of z? It is e power I pi into e power I theta. So e power I into pi plus theta. So minus z is same as e power I of pi plus theta. And similar, if z is like this, e power I theta, what is I into z? I into z is, what is I when I will get I? That is e power I pi by 2. Because cos of pi by 2 plus I sin of pi by 2. Cos pi by 2 is 0, 0 plus sin pi by 2 is 1, that is I. So I will get I. That is the reason I written I as e power I pi by 2. So e power I pi by 2 into, what is the argument of z? Z is argument is e power I theta. So what is the final thing? E power I of pi by 2 plus theta. E power I of pi by 2 plus theta. So this thing we got. And we can multiply with I, omega, anything. Suppose z is like this. Z is equal to e power I theta. If I multiply z with omega, what is the argument of omega? E power I 2 pi by 3. I already discussed. E power I 2 pi by 3 into z. And e power I 2 pi by 3 into, what is z? E power I theta. So e power I of 2 pi by 3 plus theta. So this is a rotation. This much times we have rotated the complex number z, which having the theta. And by 2 pi by 3 units, we have rotated the complex number. Now comes the important results. These are all results, just you have to remember. Important results. What are the results? If Z1, Z2 and Z3 are vertices of equilateral, if Z1, Z2, Z3 are the vertices of equilateral triangle, then Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. This is the relation you have to remember. The direct question has came from the complex number, the previous year question. That is, they given the three complex numbers Z1 and Z2 and Z3. They asked this relation, that is Z1 square plus Z2 square plus Z3 square equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. You can prove this one by simply you can take the equilateral triangle, that is Z1 Z2 Z3. and Z3 is a rotation, that is of Z1 times and Z2 times. So you can equate this and you can find this relation. And next thing, and if Z0 is the circumcenter, if Z0 is a circumcenter, if Z0 is a circumcenter of the triangle, if Z0 is a circumcenter of the triangle, then 3Z0 square is equal to Z1 square plus Z2 square plus Z3 square. This relation also important. That direct question has came. That is Z1 plus Z2 plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1 here. But in this case here 3Z0 square is equal to Z1 square plus Z2 square plus Z3 square. You have to remember. And in argument, I already discussed some locus questions, that is argument of Z minus Z0. This is the angle which is made with the value, that is Z minus Z0, which is equal to theta. It can be represented, but the most important thing is how it influences the locus. That is argument of Z minus Z1 divided by Z minus Z2. Suppose it is theta, depending on theta value, the shape will be represented. Suppose if theta equal to 0 or pi, if theta equal to 0 or pi, that is the difference, that is Z minus Z1. Suppose if I take a circle and if I take the semicircle, and if this is a Z, this is Z1 and Z2, and the angle Z minus Z, Z1 minus Z and Z minus Z. If this is theta, which is pi by 2, then pi by 2, what I can say? I can say this is Z is semicircle. And if 0 or pi, what I can say? I can say it is a straight line. Because when it is 0, that is Z minus Z1 angle, Z minus Z1 angle will be equal to Z minus Z2. So Z1, Z, Z2. So this angle is equal to this angle. So it will be 0. That is, if you see, if Z is present in the middle, Z minus Z1, Z minus Z1, that is Z1 to Z. This is the way, and Z minus Z2, this is the way. So both are same, so the angle is 0. But if it is pi, that is Z is outside. If Z is outside here, this is same, but this is like this, so it is opposite, anti-parallel, so it will be pi. So depending on the condition, suppose if they give argument of Z minus Z1 divided by Z minus Z2 is equal to pi, what does it imply? Z1 and Z2 will present in one line, and Z is also present in the same line, but the Z is far away from Z1 and Z2. So when I compare Z minus Z1, that is Z1 to Z, and next Z minus Z2, Z2 to Z, this is same. Now if it is in the middle, that is Z1, Z and Z2, that is the first thing is Z1 to Z, this is Z1 to Z, but second is Z2 to Z. So if Z is present in the middle, it is pi, angle is pi. If Z is present outside, the angle is 0. This thing you have to remember. And some more conditions can be taken, that is theta not equal to 0 and pi not equal to pi and not equal to plus or minus pi by 2. Other than these cases, it will depend. It will be a circle with arcs, that is major arcs and minor arcs. It will depend. You have to check the condition. After checking the condition, it can be easy for you to evaluate. Next, the important concept is equation of straight line. How we can find the equation of straight line? You already know what is the equation of straight line in the geometry part, that is ax plus by plus c is equal to 0. This is the equation of straight line. But in the complex, there is a slight change. That is a complex a bar z plus a z bar plus b is equal to 0. This is a straight line equation. Simply remember, the trick is z we have to represent it as y. That is, here y is represented as z bar and z bar is represented as x. Z bar is represented as x. So if I see here, this entire thing can be transformed. And here in the above equation, if I want to calculate the slope, what is the slope? Minus a by b. But in the here, we can define a complex slope. Here also the slope will be present, that which is a complex. That is complex of omega is equal to minus a divided by a bar. This is the thing, that is minus a divided by a bar. This is the complex slope. And depending on the slope, we can find whether those are parallel or perpendicular. Suppose the W1 and W2 are two complex numbers, or two complex slopes, not numbers, it is two complex slopes of two lines, because these are the straight lines equations. And if W1 is equal to W2, these are parallel, you already know. If slopes are equal, these are parallel. And slopes sum is equal to 0. Slope sum is equal to 0, then it is perpendicular. But in the straight lines, what we can say, the product of slopes, if the product of slope is equal to -1, then we can say the lines are perpendicular. But here, if the slopes or the summation will be 0, then we can say then we can say like this, that is the W1 plus W2 is equal to 0. And the next thing is reflection. Reflection in straight line. Reflection in straight line, that is, this is a line and Z1 is a one complex number. With respect to this line is already discussed, that is a bar z plus a z bar plus b is equal to 0. This Z1, if I do the reflection, I will get another point, that is another complex number, that is Z2. This Z2 I have to find. Simply substitute this Z2 here and Z1 here. What I will get? I will get a bar Z2 plus a Z1 bar plus b is equal to 0. So what is Z2? Z2 is simply minus b minus a Z1 bar, and Z2 is equal to minus b minus a Z1 bar divided by a. So this is the answer. Simply substitute and find the Z2, because Z2 we have to find, because Z2 is the reflection of Z1. These are all the geometry portion. That is again we are calculating the distance of point from line. This is a line, and we know the equation a bar z plus a z bar plus b is equal to 0, and Z1 is a complex number. And in order to find the distance, simply substitute the Z1 complex number, that is modulus of a bar Z1 plus a Z1 bar plus b divided by r times of mod of a. That is, the a should be multiplied by r. This is the difference between the geometry and the complex numbers. And there are so many circle equations. There are so many circle equations will be present. So with the help of those circle equations, we can easily find the complex number behavior. So many circle equations. So the first equation is modulus of z is equal to r. You already know the modulus of z is equal to r. What does it imply? That is it is having 0 radius, that is it is from the origin, that is the circle is from origin. The circle is origin and it is passing through r. The radius is r. So this is a circle equation and in this complex number. And now comes the another part, that is z minus z0 is equal to r. I already discussed this thing, that is z0 is a new center. It is not from origin now, and this is radius. And this is radius part. And next, the new circle equation which you have to remember is z into z bar plus a bar z plus a z bar plus b is equal to 0. This is the new equation you have to remember, and here a is complex here, you have to remember, and b is real. And from this equation, how you can calculate the center? The center here is minus a, and the radius here is root of modulus of a square minus b. This is the thing you have to remember. This is the center, this is the radius. In any circle, if you want to calculate the radius and if you want to calculate the center, what you have to do? You have to simply do this thing, that is center is equal to minus a and the radius is equal to root of modulus of a square minus b. Now there are so many locus, that is standard locus involving modulus. The argument is completed, the conjugate is completed. Now comes the locus using modulus, that is modulus of z minus z1 divided by z minus z2 is equal to k. If k is equal to 1, first case, that is z minus z1 is equal to z minus z2. What does it imply? It implies the perpendicular bisector. Suppose these are z1 and z2, this is z. These two distance is always constant. If it is equal to 1, it is perpendicular bisector if k equal to 1. If k is not equal to 1, then it will be a circle. Z is equal to a circle. Like this you have to remember. It is a simple cases, that is again the first one, z minus z1 plus modulus of z minus z2 is equal to k. What does it imply? That is the distance is equal to k, and now the k will depend. If k is equal to modulus of z1 minus z2, or k is less than modulus of z1 minus z2, and if k greater than modulus of z1 minus z2, with the help of these cases, we can say what type of locus is this one. That is z minus z1 plus z minus z2 is equal to k. Now what we can observe? If z is equal to modulus of z1 minus z2, if it is equal, it is just a line segment. It is just a line segment joining z1 and z2. But if it is less than z1 and z2, there is no locus, no real locus. But if it is greater than z1 and z2, it will be an ellipse. It is very important. And next part, same thing, but it is minus now. Z minus z1 minus z minus z2 entire mod is equal to k. Now it will depend. K. What is k now? K is equal to modulus of z1 minus z2. And what is k now? K can be less than modulus of z1 minus z2, and k will be greater than modulus of z1 minus z2. Here at what case we got ellipse? Greater than z1 minus z2. Here less than z1 minus z2 you will get hyperbola. And at equal you will get again line segment only, you will get, but outside z1 and z2. And at greater than z1 and z2 we will get no real locus. And next thing is logarithm of a complex number, which is again important thing. That is, suppose z is equal to r into e power I theta is a complex number. Now what we have to do? We have to find the logarithm, that is log of z we have to find. Log of z is equal to log of r into e power I theta. Yes. So log of z is equal to, this is a logarithmic property, we can make into addition, that is log r plus log e power I theta. So log z is equal to log r plus I theta, and log e base c, we already know this thing is equal to 1. Now log z is equal to log r plus I theta. This is the logarithm of z. That's it. Suppose if I take an example, I have to find log of 1 plus root 3 iota. What I will get? 1 plus root 3 can be represented as 1 plus root 3 can be represented as 2 into 2 into e power I pi by 3. It can we can represent. So what we will get? We will get log of 2 plus I pi by 3 we will get. So this is a logarithmic of 1 plus root 3 iota. Like this you have to solve. Now I will take some questions. The entire complex number is completed. This is basically the theory. The theory is too vast, but it is mandatory to explain the theory. Now I will take some problems. The first problem is z is equal to 2 plus 3 iota. I have to calculate z power 5 plus z bar whole power 5. I have to calculate 2 plus 3 iota. What is 2 plus 3 iota? It is z. So 2 plus 3 iota whole power 5 plus z bar. I forgot to say that is z is equal to 2 plus 3 iota. It is just the reflection I said. What is the reflection? What does it change? It changed positive y to negative y. So z bar is simple 2 minus 3 iota. Just replace iota with negative. So it will be 2 minus 3 iota whole power 5. Now use the binomial expansion. That is 5c0 2 power 5c0 2 power 5 3i power 0 next plus 5c1 2 power 4 3i power 1 plus 5c2 2 cube 3i whole square plus 5c3 2 square 3i power 3 and next 5c4 2 into 3i power 4 and plus 5c5 2 power 0 3i power 5. This is the thing. And if I do addition with 2 minus 3 iota whole power 5, what I will get? I will get same, that is 5c0 2 power 5 minus 3i whole power 0 plus 5c1 2 power 4 minus 3i whole power 1. So if you observe carefully, this negative, this one will be gets cancelled. So what are the things we got as even? That is 1 if you observe carefully, and next if you observe carefully the 3 and the next 5, these are all gets cancelled, and what are left? 5c0 2 times of 5c0 2 power 5 3i power 0 is left, and next 5c2 2 cube 3i whole square is left plus 5c4 2 into 3i power 4 is left. That's it. These 3 is left. So simply calculate this. 5c0 value is 1. So 2 power 5 value is 32 plus 5c2 is 5 into 4 divided by 2. So it will be 10. 10 into 8, it will be 80. And 3 iota square. Iota square value is minus 1. Minus 1 into 3, it will be minus 3. So it will be minus 240 entire thing. And this one 5c4. 5c4 value is 5c1 because NCR is same as NCN minus R. So it will be 5c1 and answer is 5. 5 into 2 into 3i whole power 4. I power 4 value is 1 because I square whole square is 1. 1 into 3 is 3. So now I have to compute the entire thing. That is 2 into 32 minus 240 plus 5 into 2 is 10. 10 into 3 it is 30. So 2 into 32 plus 30 it is 62 minus 240. One second guys, it is 5c2 value is 5d value is 10, 2 cube value is 8, 3 whole square value is minus 9. So it will be 80 into 9, that is minus 720. Sorry guys, it is minus 720. It is minus 720. Yes, it is minus 720 and it is 810. Here also it is 5. 3 power 4 it is, I forgot to multiply 3 power 4. So if I multiply entire thing, I will get here 810. So at last what I got? 2 multiplied of 32 minus 720 plus 810. These values by these values. So 2 multiplied by 32. 32 plus 810. 810 plus 32. 842. 842 minus 720. What I have to get? 2, 5, 1, 152. 152 into 2. What I'm going to get? I'm going to get here it is 32. That is I will get 4, 10, 344. That is 304. This is the value I will get here. Next question I will take. Now the next question, that is let Z1 and Z2 be two complex number. Z1 and Z2 be two complex numbers such that Z1 is equal to I Z2 bar, and they given argument of Z1 divided by Z2 as pi. Then they given options. Option A, argument of Z2 is equal to pi by 4. Option B, argument of Z2 is equal to minus 3 pi by 4. And third option, argument of Z1 is equal to pi by 4. And fourth option, argument of Z1 is equal to minus 3 by 4. Let's analyze the situation, that is Z1 and Z2. They given Z1 equal to I Z2 bar, that is I into conjugate of 2. What I can do, I can simply take argument of Z1. Argument of Z1 is equal to argument of I into Z2 bar. That is argument of, now comes the property of argument, that is argument of I plus argument of Z2 bar. Yes, here what is argument of I? It is pi by 2 plus argument of Z bar can be written as minus of argument of Z2. Yes, this is argument of Z1. And now again this relation is given. Argument of Z1, this can be written as argument of Z1 into argument of Z2 is equal to pi. So these entire relations, that is argument of Z1 plus argument of Z2 is equal to pi by 2 here. But in the above case, argument of Z1 minus argument of Z2 is equal to pi there. So what I can do, I can add these two things, and what I will get, argument of Z1 is equal to pi plus pi by 2. It will be 3 pi by 2. So Z1 argument is, one second guys. Sorry guys, here one mistake is I have committed. That is this is not Z1, it is Z1 bar. It is not Z1 in the question, it is Z1 bar. So if it is Z1 bar, it is negative. This is negative, so we cannot subtract, or we can add them. It is negative here. So these two can be cancelled. So 2 minus 2 times of argument of Z2 is equal to 3 pi by 2. So it will be argument of Z2 is equal to minus 3 pi by 4. Now what is argument of Z1? Argument of Z1 we have to substitute here in the above, and now we will get argument of Z1 as pi by 4. Because argument of Z1 minus argument of Z2, what we have to go, we have to get how much? We have to get pi, because pi by 4 minus of minus 3 pi by 4. What I will get? I will get pi by 4 plus 3 pi by 4, and it will be 4 pi by 4. It will be pi. So the above relation will be satisfied here because the given argument of z1 minus z2 will be pi. So like this you have to solve. Now comes the important question, that is value of minus 1 plus iota root 3 divided by 1 minus I whole power 30. What is this value? Options are given as 2 power 15 minus option B 2 power 15 iota, option C minus 2 power 15 iota, and option D 6 power 5. We have to find the value. So how we can solve this value? That is, suppose if some student do like this, is it good to do like this? Splitting this one, yes, the first step is correct. After splitting, opening this one and by using the binomial, it is a very tedious, and finding the answer is very tedious. So what I can do, I can represent this complex number into the polar form or Euler form. Minus 1 plus I root 3. What is the answer? 2 into this is the second quadrant. So the second quadrant argument is pi minus alpha. So pi minus pi by 3. So it will be 2 pi by 3. So e power I 2 pi by 3. So this is answer. So the entire thing can be represented as 2 into e power I 2 pi by 3 whole power 30 divided by 1 minus I now. 1 minus I modulus is root 2. Yes. Like this I can do. So it can be simply, what is the quadrant here? The quadrant is y is negative, it is positive. The fourth quadrant is simply tan inverse 1. It will be minus pi by 4. So e power minus I pi by 4. So root 2 into e power minus I pi by 4 whole power how much? 30. So simply do this. The above will be 2 power 30 into e power I 2. Here this thing will be cancelled 10 times. So 25 divided by, here it will be 2 power 15 into e power e power 15 pi by 2. Yes. So this thing will be cancelled, that is 2 power 15 into this thing will be e power I 2 pi into e power minus 15 pi by 2. So when I calculate this entire thing, what I can get? I can get simply e power I 3 pi by 2 into this entire thing. If I calculate, I will get e power I 3 pi by 2 into 2 power 15. But one thing you have to remember, what is the value of e power I 3 pi by 2? E power I 3 pi by 2 is 3 into 90, that is 270. What is cos of 270? That is 180 plus 90. 180 plus 90 and cos 90 is 0. So it will be minus 1. So answer will be minus 2 power 15. Like this you have to solve. Minus 2 power 15, and there is an iota symbol because it is cos 270 plus iota sin 270. Sin 270 is minus 1 into iota, that is minus I. So if I multiply minus I here, what I will get? Minus 2 power 15 iota. So this is answer. I will check if I get another questions. That's it, guys. The remaining questions you can take as the homework. That's it, guys. And if you like this video, subscribe to this channel to get the notifications of the channel. And up to now, what I discussed the entire complex numbers theory. And if you want to practice some more PYQ, you can practice in the PYQ sections. And if this session is helpful for you, you have to subscribe to this channel to get the next upcoming videos notifications. And also, please practice PYQs of complex numbers, because the complex number has the highest weightage. So do the questions, guys. That's it for the video. Thank you.